Hello, this is Noah Lee, and this is my Update 2 submission for CSC313 on graphics and visual computing for our final project. I wanted to first apologize for missing the first update. I know I won't get the credit for it, but I did want to address the fact that I missed it. I forgot to check the assignments available for graphics, and I missed the announcement. I didn't see it in the calendar, so that's entirely on me. I apologize for that. I will quickly go over what I did at the beginning of this week and the end of last week. The primary things that I worked on was handling the enemy car, initializing the enemy car, handling the enemy car loop. The primary things this handles is doing the enemy car itself, moving the enemy car to track the closest player, and then handling other features that are implemented later in the week. The implementation of moving the enemy car is very simple. We have a random function just to have the enemy wiggle just as a kind of signal of which one the enemy is. We have a tracker for whichever the closest car is. We iterate over the list of all cars. Then we find whichever one is closest based on a simple distance on the square root of the value, simply using Pythagorean theorem. We have a function for on-distance threshold. This is a future-proofing for when we handle a function to cause a blast or some kind of projectile from the player or a push. This is just to say that we can trigger this on certain interactions. We then handle whichever car is the closest and move towards the closest car. Again, just using a relatively simple Pythagorean theorem on the speed to get a distance that the car should be moving. Adding the on within distance threshold, this is very simply, it takes the enemy car and the closest car, checks the distance, and then it just prints out whenever it is closest to the enemy car. These are passed in just to be able to have both of these be available here if we need them later in the function. Moving on from there, one of the things that I added is implementing the falling feature for falling off of the mat. This uses a try-fall function that I created, which passes a car variable in. We take the position of whatever our floor is and get the edges of that based on the vertices, just based on the position of those vertices. We get the current car position and can then compare that to the position of the edge of the mat. If we exceed the edge of the mat, then we change the position at the falling speed. I do have a to-do note here for locking movement to signify that you have fallen off and the game is now over for that user, and some kind of notification or animation for the falling to signify further that the enemy has fallen, that you or the enemy has fallen. For the implementation of try fall, within the loop, we have a call to try fall on each individual car. If this is used on every car that we have rendered, along with the enemy car that is used to check when or if the enemy falls. This is basically a future-proofing to handle whenever we have the completed shell function. Right now, all this does is just cause the user to fall if they exceed the edge of the mat. Other than that, the only changes that I made were mild changes to other portions in the code, moving back some unused functions and deleting some other unused methods. Along with that, I added the terrain generator to dynamically generate our map. Excuse me, not dynamically, but on call. This generates a very simple height map. We then add a small bump in the center of the map to signify a kind of ring in the center. All this does is add a small bump in the center of the platform, along with a very simple platform that we use for the mat. I'll go ahead and try and show off the program. It might be a little bit slow, so I'll try and show it off as best I can. As you can see here, we just have the ability to move around this mat. We can show off the small bit of bump we have on the floor, along with a very basic texture that I just implemented by changing the color on each individual vertex of each triangle. And then showing off the falling function, I can come to the edge, and when I fall off, I just start descending off the edge of the map. Okay, thank you very much. That's everything, and bye.